Hello, and welcome to Create Dynamic Scratch Projects with the Power of Conditional Statements. I'm Erin, aka Algorithmer, on the Scratch team. I'm a learning resource designer for Scratch, and I'll be your session facilitator today. A copy of the slides I'm sharing in this session are available on our website in our Learning Library, where you'll also find many of the resources I'll link to today. This is the third in our series of 6 sessions on leveling up with Scratch. Each session focuses on a different topic, and my goal with each session is to give you a variety of ways to approach creative projects on each of the 6 topics. The Scratch Foundation is grateful to AT&T for its support of this workshop series. We have partnered with the Achievery from AT&T to provide free beginner and intermediate creative coding lesson plans on a variety of topics for educators, caregivers, and learners, and I'll share some of those resources throughout the session today. To code along with me today, you can go to scratch.mit.edu and click Create, or log into your free Scratch account to save projects. For anyone new to Scratch, we have Getting Started resources on our platform and in our Learning Library with lots of helpful information. But a few quick basics. The Scratch Project Editor screen is where you'll create projects in Scratch. If you aren't already on this Project Editor screen, click the See Inside button, which is available on all projects. Any character or object you can code is called a sprite. To code projects in Scratch, start by dragging out a block from the block palette to the script area. You can click the block to try it. Then snap another block to it to build your script. If you chose when the green flag is clicked to run the code, click the green flag above the stage. You can choose your preferred language or color mode, original or high contrast, under Settings, and see our tutorials or debug buttons for helpful tips when creating projects. When logged in, you'll also have access to Remix projects, which is making a copy of someone else's shared project to modify. I highlight some remix opportunities in this series. Or share a project that you created inspired by this series, using the Share button to make your project public. We have a lot to talk about today, but I do want to share one slide to ground us in Scratch's creative learning philosophy. And for those newer to our workshops and creative learning materials, I encourage you to check out our Scratch Creative Learning Philosophy resource in the Learning Library on our website. As facilitators, we want to support playful learning and tinkering mindset values so that participants can engage playfully in projects that are meaningful to them and elicit joy, collaborate with peers to experiment, share, and celebrate ideas, allowing for multiple pathways of engagement to foster a wide diversity of projects and supporting different experience levels. We want to help them develop a mindset that is comfortable with the discomfort of getting stuck, making room for risk and iteration, as well as develop a mindset that thinks critically about strategies for getting unstuck, saving space for the process to start again, and help them imagine what's next. We often call this productive struggle. And this applies to you too. Remember that we are learners just as much as our learners. So as we explore today, give yourself space and grace, and remember it's okay to get stuck or feel uncomfortable. You don't have to have all the answers right away. Just a curious mind and an excitement to try new things. That is part of the process and how we develop and model a growth mindset for our learners. We have some learning goals, specifically here with conditional statements that we're talking about today. We're going to try to identify good use cases for conditional statements in Scratch projects, do some hypothesizing and experimenting and observing to see the difference between different conditional statement blocks. And of course, as always, debug unexpected behavior, one of my favorite things to do. Remix some starter projects, reflect on the creative process and our finalized artifacts that we may come up with. And then I always encourage folks to share those projects in the learning community when they're done. Let's jump into talking about conditional statements. We have a resource about conditional statements in the library. Again, all these links will be in the session wrap-up email for you in the session slides. So don't feel like you have to scribble copious notes here. But those conditional statement resources will be helpful. If you're not familiar with what a conditional statement is, let's talk about it. So some Scratch programs are static. The outcome is fixed, and the same thing happens each time. And some are dynamic. They can be capable of action or change each time they're run. In this example you see here, in the one case, uh, they have an answer that's just given to them. It's more informational. But in another case, they can actually type in what they think the answer will be, and then they'll get a response. Is that correct or incorrect? In order to create these dynamic programs, the programmer can use conditional statement blocks to give instructions on how the project should respond in these different circumstances. Many students first encounter the computational concept of conditions in the context of a game, like a chase game or a Pong game, when they want to adjust the outcome based on if the sprites are touching or if a sprite is clicked or touched with a mouse, etc. These conditional blocks can be found in the control blocks category. And and the thing about conditional statements is they can be true or false. They are, Boolean, so true or false. In the case on the screen, as an example of this, if the sprite is touching the mouse, this first conditional statement says, if that statement is true, do X, Y, and Z. So if the sprite is touching the mouse in this first statement, that statement is true. If it's not touching the mouse, it is false. And so the first sprite's conditional if then statement says change the whirl by 25 as long as the sprite is touching the mouse, as long as that statement is true. The second sprite has a slightly different conditional statement. It's similar, but there's the addition of this else portion. And in there, we can have something happen if the statement is false. So in this case, the else portion clears that graphic effect on the sprite when it's not touching the mouse. I'm going to switch over to my Scratch screen where I have this project up so you can see what this looks like. So here I'm going to click the green flag. And so here we have our simple if-then statement. So touching the mouse, it's whirling. Not touching, it's not whirling. This sprite, by another example, if it's touching, it's whirling. But if it's not touching, it clears those graphic effects. Now, you'll notice it's kind of jumping here, in part because when my sprite is turning, all of a sudden, it's not touching the sprite anymore because some white space has been introduced in the whirls. So it gets a little tricky here to debug and troubleshoot what you're looking at. But this is a nice example of just comparing and contrasting the difference about an if-then versus an if-then-else, and what kind of control you get by having a similar but slightly different statement there. Our maze starter project is another example of how a simple if then statement could be used to stop a sprite from walking through walls in a maze. So, if the sprite is touching a color of the maze walls, the condition is true, and the script reverses the move, giving the illusion of resistance when the walls are encountered. And this concept of touching color and reversing movement can also be applied to other games like platformer games. Platformer games tend to be a very leveled up experience, right? It can be challenging to make those, but also mazes themselves could be leveled up by trying to figure out different formations to create that your character needs to move around. Maybe effects at the end, like if they solve so many mazes, they win, or reaching a certain point in the maze triggers something, or you build in other roadblocks that your sprite may encounter. So I love this as an example of a type of project where you can start pretty basic, but then you can add definitely opportunities to level up for those students who are ready for more of a challenge. The other reason I really love to show this maze project as an example is that there is often more than one way to arrive at a solution. So you'll see on the screen in this example, there are three similar but different approaches for stopping the sprite from walking through the wall. And what I love is that while there may be slight differences in the results here, or one might be faster, more efficient to code than another, or maybe the behavior of other sprites may change the approach that you use, each of these approaches is valid and accomplishes the goal. And what I love to highlight this for is because we really want to celebrate variety. We want to explore with learners the different approaches that they took and why they chose the one they did. And I think this is also a wonderful opportunity to encourage iterating and trying new things. So, as your students are working with conditional statements, it can be really nice to give them the freedom to explore and then to maybe come together as a group and see the different approaches that people used instead of just kind of giving them one way to try this. It can also be really nice to look out for debugging opportunities. So, in two of these conditions, in two of these examples, for example, I have the condition inside of a forever loop. What is the difference if the conditional statement is inside of a forever loop or not? What might be the benefit? Um, a little hint there, if the conditional statement is wrapped inside of a forever block, the program is continually checking to see if it is true. This kind of brings me to another thing that I really love to do when exploring conditional statements, which is just take some time to examine, hypothesize, observe the differences and what happens in different scenarios. So, in our student facing coding cards that are in our conditional statement resources, we've shared a few examples of experiments with wait until versus repeat until. If something is true or false, then versus if then else. One of the things that we just saw, right, with the maze was that there's often more than one solution, more than one way of coding a program to get a similar result. But other times, using one block over another could produce a wildly different result. So, what I love to do is really encourage experimentation. And I love to do this hands off at the start. So, I might pull up these scripts here and start with let's just examine and look at these code sequences. And I want you to kind of hypothesize before you test the code. Write down what do you think the difference is between them. Then we will recreate these code sequences in Scratch, drag the blocks from the script area. And then what do you observe? Was your hypothesis correct? And then maybe we talk about the use cases. So each block could be useful in different circumstances. When might you choose one over the other? What changes when these conditional statements are used inside of a loop versus outside of a loop? So here are the blocks that I have pulled up here. And so let's just do a quick observation. So this one says repeat until the mouse is touching repeat until it's touching the mouse pointer. So it's repeating, repeating, repeating. And then once I touch it with my mouse, it stops. What happens if I put that into a forever loop? It stops, but then once I stop touching, it starts turning again. And then it stops, and then it starts turning again. Another one is wait until. So this one, nothing, nothing. And then the minute I touch it, it turns, but only once, right? What happens if I put that in a forever loop? Turning, stop, turning, stop. And then here's another one. If touching the mouse, then turn. Nothing's happening here. Why? This is a good example of sort of being able to talk through these things can sometimes be very revealing. I feel like this one in particular, students using the if then outside of a forever loop is often a big debugging thing because they aren't thinking about, oh, it's just checking once at the very beginning of my program and then it's done. It's done checking. It's versus if I put it inside of a forever loop, now it's working because it's constantly checking. Is this touching the mouse pointer? Is this touching the mouse pointer? And so it has a totally different functionality here. Now, maybe you don't need that functionality. If we went back to our mazes, you'll notice that some of these aren't in a forever loop because we don't need it to check continuously just at a given moment. When I move it forward, is it now touching a wall? Oop, move it back, right? Or is it touching this color? Move it back. Versus other times, I may want it to do that continual listening. And so I think it's really helpful to have that ability to talk through these things and think about it um, out loud because it often is very revealing when we're trying to debug these problems. And I also will say that I feel like some blocks like repeat until or wait until are probably highly underutilized in Scratch. I think a lot of kids tend to gravitate toward that if then statement, but I encourage you to have them check out the wait untils or the repeat untils because sometimes those are much more effective or much more efficient at getting to what they want to do depending on the context. One way that we can create an entire program using conditional statements is an example in this Achiever unit we have called Create a Math Game. And we have a starter project called Math Game as well. This is a quiz game, which always seem like they're popular with Scratchers. And what you need to do is to create a simple conditional statement that checks the answer to a question posed with the ask block and then when the user responds, you're checking their answer and telling them if they got it correct or incorrect. You can go to that Maze Starter program and remix the sprites to change the expressions, the mathematical expressions, or the expressions of the of the character itself when you win or lose. You can adjust those animations. We have lots of tips and tricks for remixing sprites in our sprite creation resources, which will be linked here, which you can see afterwards. But this is a really nice beginner way of interacting with conditional statements. Then the question becomes, how can we level this up? So if you look inside of that starter project, you'll see this first script shows using the ask block, checking if the answer is the correct one, and then doing something if it's correct and something if it is incorrect. When I scroll down, I see this second version of it, which is leveled up, which at face value may look very intense, but it is utilizing variables and our operator blocks in order to make our asking and answering more efficient and more automated. So, the way that I tend to approach this is okay, before we dive into the code, let's start by decomposing the question that you want to ask. So, what parts of the question could change with each new question, and what parts would remain the same? So, here, where the numbers appear in the question, what is 2 plus 2? Those numbers are going to be the changing parts. But the what is, the question mark, the plus, those are all going to remain consistent. So then we have to think about how do we want to represent those changeable elements? And this is where using variables comes into play. And that's an opportunity for us to start to talk about variables. Side note, we have resources on variables also in Learning Library if you would like help figuring out how to start to talk about variables. But essentially, I like to always kind of describe them as like a container that can only hold one thing at a time, right? So I can take things in and out of the container, I can switch out what's in there, but it can only hold one thing at a time. So what I can do is store information in these containers by using blocks like this set variable block, which you see at the start of this. And in this case, you'll see I've also used this operator pick random. And so I've set a range of numbers and I said, you make the choice. Put something between 1 and 10 in variable A and something between 1 and 10 in variable B. Now I have to write a question in order to utilize those variables. So you'll see that I've used this join block here so that I can connect these two together. And this is where then we can decompose and you're separating out the parts, and sometimes you have to use join blocks inside of join blocks, right? So again, it may look intense, but once you start to sort of break it down and decompose it, hopefully then students will feel less intimidated by trying this and using these operators and like these join blocks or these pick randoms. And then you see you could write an equation to get the answer. So in this case, you'll see that equation here. If the answer that the user has provided equals A plus B, then correct, otherwise incorrect. Now this is automated. I don't have to write 24 questions here, repeating the same blocks over and over. I can actually have the system do it for me, which is really fun and exciting, and an interesting way of leveling up and thinking about how to develop these programs. We have an achiever unit called arithmetic operators, where you can learn even more about these operator blocks. Rather than repeat that same question over and over in the same order, we can also use the pieces that we just created in this version of the math game, right? And introduce that randomization as I was talking about. So that's where we're using those blocks like pick random. And when we're thinking about why it might be necessary to use pick random in a variable rather than just pick a random thing and put it in the join block, that can be another great debugging opportunity, right? The hint here is that we need those numbers to stay consistent between the question and the answer. So if it picks a random thing, but we don't know what it picked when it's asking the question, then when you're checking the answer, things aren't going to align. So for that consistency's sake, we need to store whatever random thing was chosen, right, in a variable. So again, another debugging opportunity, maybe a chance to introduce some errors and have students try to work out what's going on, what's causing the problem, and how can we solve it. So maybe you don't even want to introduce variables at the start. You just want to start with a pick random and then try to have that debugging conversation. And again, since there's often more than one solution, students might try creating lists of numbers that can be selected from. Completely valid solution, right? Maybe they have their own equations that they want to create versus using a pick random. You could set up custom my blocks to create a single block with inputs for each number in the equation. In our coding cards, we share some examples of how you can use, for example, operators in a different way to make sure more than one condition is true in order to make the statement true. So you can really get very diverse in your solutions here, and in your coding experimentation. And so I think this is a really fun way of being able to have something here for beginners, but also if you have those students in your class that have more experience with some of these things, there's opportunities to scale this up. And you're still all working on a math game, but you're doing it from different approaches, you're exploring different aspects of it. And so you still have that kind of consistency of experience in terms of what you are creating, but everybody's is going to look different, which I think is the goal, right? It's fun. I also love to think about this not just in the context of maybe like clicker games or maze games or even quiz games, or excuse me, even mathematical concepts, but the idea of storytelling. These can also be used in that context. And so, one of the starter projects we have is this community quiz. And I think it's a great example of using conditional statements in storytelling or for informational projects. So, one of the things that you can do when you are in that program is you can actually see inside and explore some of the code for the background to see where it's asking questions and then what it's doing. This is involving a lot of different blocks. I'm utilizing Speak so that people can hear the questions out loud. I'm utilizing some different animations. I don't think I had the volume turned on or the audio turned on for this tab, so you probably can't hear the jazzy opening music. But this is a way of us being able to do a couple of things. We're talking about the community guidelines with this project and giving them a little quiz. So we're doing some, uh sorry, it's reading it out loud, so hopefully it's not coming across jumbled for you and not picking up that audio. But it's an opportunity to be able to explore the community guidelines, try out some conditional statements, do a little storytelling, and then you can add animation here. Fun things can happen, right? So it combines a lot of these ideas all together, which is a real community guideline. No yellow aliens allowed. We can try it. No, sad. And then it tells us what the right answer is before we move on to the next question. So that is a fun one, and I love to think about these things also in terms of how they can be utilized in storytelling projects. Another thing is that I love to have students experiment with is this idea of the unexpected. So, one of the great things about conditions is that you can have things change based on certain user behaviors. But what if they do something that you hadn't planned on? Newsflash, students love to do things sometimes, right? That we haven't planned. This is a great opportunity to talk about the topic of user testing, right? Have someone else in your class try out your game, see if they find any bugs. And then what did they do anything weird that you hadn't expected? And then how do we account for that? So, what if the user, for example, gives you bad or incomplete data? How can you ensure that the information that you need for your conditional statement to be true or false gets to you in the proper way? So, for example, in this code on this slide, what would happen in the first script if the user typed horse or the number 8 or a colon, right? These results mean that the character shown on the screen wouldn't match the answer they provided. Because if I said, "What's your favorite animal?" Cat or dog, you said horse. And I can't show you a horse because I wasn't anticipating needing to show you a horse. So in our Achiever unit, get the answers you want, we demonstrate using a conditional statement like repeat until, and then have it repeat until only very specific answers that you were asking for are given to you. This ensures that when you move on in that conditional statement, that everything works as expected, that you've kind of accounted for unexpected behavior. They basically aren't allowed to give you bad data here. And then placing that ask block inside that repeat until means that that user is only able to choose between those two answers. So otherwise they'll just keep getting the question over and over. I also find it really helpful to provide, what is the response that I am looking for? Again, this is another debugging opportunity. As students are thinking about this here, if they don't tell me what to type in, how do I know how to answer, right? So I might type C or D for cat or dog, and that won't work because the system is looking for the word cat or the word dog. And so this is again just a way of getting students to think about that user experience and how do you help your user understand how to use your program. Maybe it's that you don't put it here but you share it in the instructions on the project page. That could be another way of handling this, right? There's often more than one solution, as I love to keep pointing out. So just different ways of being able to approach these projects. And I think that as we get more sophisticated in our projects, as we get more experience bringing up these sort of user experience and user testing opportunities, both gives them a real world example of how products, especially digital products, are being produced, right? We always have a QA session before we put out new features. And why? Because of things like this. And then sometimes still things will come up, but it's a good way of understanding how to get constructive feedback, how to take that in, how to solve for that. And so, really, I think a very helpful experience. Let's talk about nesting conditional statements. That's another opportunity to level up a project. And this is where you have a conditional statement that's placed inside another conditional statement. So the first conditional statement is checked. And depending on if it is true or false, then the program may move forward to check the nested conditional statement inside. So in this example, I've got in this project that I'm showing here, I've got the score being checked first. So it's seeing if the game should continue. Has it reached the winning score or not? Then, if the score is below that certain value, um, points are assigned if two sprites touch, right? So the game is continuing on. They're having a continuing opportunity to earn points. And then there's another conditional statement inside here that's controlling the costume changes of the pufferfish. So you've got a couple of nested conditional statements in this example. And again, I love to just always highlight there are many pathways to accomplish a similar goal. So you'll see a different solution on this screen that says, like, repeat until the score is 10 instead of if the score is less than 10. So this student could accomplish the same project, but approach it using two different conditional statements. And the result might be exactly the same. And this is a great opportunity to talk about it. And so that's why I love leaving these things more open ended for students to explore and doing some of that kind of hypothesis and testing and observing early on, because it opens up the possibility of using different blocks. And so everybody's program looks different. And I love the variety. This project is one of the ones that I go into more in depth in the resources on conditional statements that are in the Learning Library, and you can see some of these example projects. You'll notice it's using all sorts of different things, like distance to the pufferfish can also determine like a certain goofy face, and these are things that just again a, a lot of fun ways to kind of add sophistication to your game, right? You can have a really great starter project where the fish touch and a noise happens or something, and that is great. That is a wonderful beginner way of using those conditional statements. And then we're just going to kind of keep layering on these levels of sophistication, fun things to try. And trust me, when you start nesting conditional statements, you're going to have some a variety of debugging opportunities that will come your way, right? Because one of the things that we have to consider is this idea of sequence. This comes up a lot when you're first learning to code. And we talk about maybe doing a little. If you ever heard of rubber ducky debugging, I have one on my desk, right? The joke is that you like talk to the duck and you explain your issue to the duck, and then by talking it out loud it may reveal where the issues are. You could also use a human. You could also talk to a human, right? And so talking through these sequences can make a difference. And when we are, like I said, starting to nest these conditional statements, it's a great way to introduce some kind of code reading challenges, or talk this through in order to get through some of that debugging. So, for example, when I'm looking at the project on the screen, I might say, "Can you tell which is the cat script and which is the dog script based on what you're seeing on the screen?" And then maybe, "What do you think the differences will be if you adjust the order of the nesting?" So this is another time where I might start hands off and say, "Okay, what's your hypothesis of what will happen?" And then we create these scripts and then experiment. So, click the mouse when it's touching each sprite. When it's not touching each sprite, what did you observe? Look at the code stacks for the cat and the dog. They use the same blocks. What's the difference? Well, the difference is the sequence, right? Which conditional statement is nested? Did the order make a difference? Well, in this case, quite a lot, right? So talking through that code out loud with a peer, or as a class could be really helpful to test that understanding, and really bring home the fact that this sequence is important. In our student-facing coding cards and our guide on conditional statements, I provided some additional examples for debugging conversations. But let me pull up. So here's that cat and dog. So we can just sort of look at it quickly together. And so you'll see the cat script. If it's touching the mouse pointer, now it's reversing its turn, right? If it's not touching the mouse pointer, the else says to turn one way. And if it's touching, says to turn the other. And then the question is mouse down. Here, when my mouse is down, and you can see it's down because I have my little note that comes up on the stage, nothing's happening. But if I touch the cat and have my mouse down, now something's happening versus the dog. This one, you'll notice the nesting is different. Here we have mouse down as the initial statement, and then this touching the mouse pointer is nested inside. This one is reversed, right, for the cat. So in this one, I can put the mouse anywhere and it's going to change the color of that dog. And then really it's about, am I touching the dog? And it gets a little glitchy when I do it on this screen. So let's do it on the screen. And sorry for the flashing lights. I hope this isn't bothering anyone who's photosensitive. You can definitely slow this down if that is the case with folks. But this is just one example. You could use sounds instead of, color changes. If you do have photosensitive viewers, you could use just a host of things in order to bring these points home. It's just this example of we're using the exact same blocks, but depending on that nesting order, it can have these dramatically different effects. And I think that that is just a really fun debugging experiment that I love to do. And it's like a goofy way of exploring these topics, right? And so you can create all sorts of fun challenges based on things like that. Another thing that I love to do is this idea of maybe I need help setting a condition. So if I go back to my fish game for a second, one of the things that you'll notice is that when I'm getting close to the fish, close to the puffer fish with my angelfish here. Is that an angelfish? um, you'll notice that the face changes, and then when they touch, the face changes again to something else, right? So wink when they touch, kind of annoyed, blowing bubbles when they are close. Well, how do I determine that distance that I'm looking for between the fish and the puffer fish in order to get that uh, costume change to happen? Visually, when I'm looking at it here on the screen, I don't know how many pixels that is, right? I maybe can't tell that by just looking. I could, potentially be here looking at the X and Y values that I'm seeing on the right area. That is one way. But again, that's kind of a lot of math for me and maybe not the easiest thing for me to visualize. And so I can actually use some other techniques. Let's write another script here. And I'm going to say forever say, and I want to know the distance to the pufferfish. So once I click this, you'll notice now my sprite is acting like a reporter. It is telling me the distance to the pufferfish. I'm using the blocks. I can take this away, the script away, once I figured out the number that I want here. But right now I'm using them in service of this project creation. I'm using it in order to help me judge what kind of condition I want to set up. So if I notice that here I'm at, 131, here I'm at 150, here I'm at 120. Okay, well maybe then when I'm looking at my distance, which I think is actually over here in this script, distance to fish, I'm going to say, okay, distance to fish has to be less than 150 because in my just sort of tests here, I'm looking at the numbers, the readings that I'm getting, and now I have the ability to figure out what that number should be. And you'll notice the fish sort of also gets nervous and sort of changes its look sometimes as they get closer. Or excuse me, it gets as it's approaching the pink. That's what it is. It's when approaching the pink of the coral that the fish is actually opening its mouth. So when it's touching the color. How do I know if it's touching the right color? Again, I could use, touching color. I could have it say if it's touching the color. So here I'm just going to duplicate this for a second, and you'll see the fish is over here. I'm going to stop it just so it's easier to tell. Fish is over here. Is it touching the color? That tells me false. It's not touching pink. Is when the fish is over here, is it touching pink? Yes, that's true. So that's another way of being able to see what if the condition is true or false. You can actually just separate out these blocks and click on them in order to get the readings to understand if that statement is reading true or false in a given moment. It's really helpful to understand what the program is doing. For instance, there's another pink here. This is the starfish. When I touch this, oh, that's also true. And so this could come up in the context of a game. We'll be talking a lot more about debugging in our final session in this level up series. And so you may see this example come up again. But what might throw me off is maybe I'm not expecting it to open its mouth and react when it's touching that starfish because I haven't realized it's the same pink as the coral. And so by being able to check these conditions at any given time, is this thing reading true? No, this is false because that's a slightly different color, right? So I can go around and I can test these conditions and then I know what I want to put in this block. So that's also, again, a really helpful thing that you can do. Um, if I am here, you'll notice even though it's not rounded, I can still stick it in this say block. And so you'll see here it says, nope, it's false. I'm not touching the color. I'm not touching the color. Now it's true. I'm touching the color and you see the mouth open. Again, not touching the color, not touching the color. Oh, now it's true. My mouth's open. So again, just a way of actually using Scratch to help you understand the conditions, what's reading true, what's reading false, so that as you are setting these things, it's a way of debugging them and figuring out why is this working for me or not. Sometimes there's also check boxes here on the side that you can check to have the stage monitors come up on the screen that can also report to you the information. But not everything has it. So this is the other workaround that I like to use. I would be remiss if I let you lead the session without also highlighting some new blocks that just launched this week that I am super excited about. And that is these face sensing blocks. And so here's another opportunity to use conditional statements, but also with our new face sensing blocks. So this is an extension. So you can choose to use these blocks or not. They can be found in the extension library. And what I love about these is they're AI powered blocks. They use a machine learning model that can detect if it sees a face and then makes a prediction about where the nose, eyes, ears, mouth, etc. are. But what's wonderful about these is that when you're using the face sensing blocks, only your computer can sense your face. Of course, I was recording myself with an external program when I was doing this. So that's why you can see my face here. But when anybody else is accessing your project, no data is being stored or sent to Scratch or any other site. Only you can see your video, only you can see your face. When you get a thumbnail as you're sharing, it does not capture your face. So these are really fun and just also safe and a creative way of exploring these possibilities of AI. So in this case, what I'm doing is you can see I'm tilting my head, and that is changing the movement of my little ghost cat. And by moving my head, I can move the cat back and forth. And then I have a separate slider up there that kind of can lighten or darken the mood of the scene. If you came to my backgrounds session last time, we talked about kind of setting a mood, right? So here's my mood setting with my lighting, with my brightness. So to get those, you go to the extension and then you choose face sensing. You'll have to allow your camera. I did, so you can see me here. And then you'll see under this face sensing category, there are blocks that say when the head tilts left or right. What I did find when I was doing my little experiment here was using those, they were just too sensitive. Like, I found myself, I'm a bit of a, mover talker, right? As you probably noticed. So they were a little too sensitive for me for what I needed here. So I wanted to have it be a specific, degree of me really turning my head before this action happened. So how did I figure out what that degree was? Well, I used my say block trick, of course. So here, I'm having my cat tell me, "What's my head tilt right now?" Okay, it's 90. "What's my head tilt right now?" It's about in the 50s, 60s. Okay, what's my head tilt right now? Okay, it's in the hundreds. And so I used that information in my conditional statement. So I said, you have to tilt your head significantly before it triggers this walking motion that I've set up here. Another fun thing that I can do is then, of course, say something like, okay, if it touches a nose, then, makes the cat jump in the air. So now I'm moving, I'm getting my body into this. I'm using different parts of my face from my head tilt to my nose touch in order to create this program. And what I also love about this is it really can bring up accessibility conversations, right? And so what if your audience or your players have dexterity conditions like limited, hand dexterity? What if you just want this level of control to be able to use the face versus using a mouse or keyboard keys? And so this could bring up wonderful design considerations. Who are you designing for? What kind of inputs could you use here? Maybe you want to have both face tilt or mouse key or keyboard keys control how this little cat moves. So lots of different ways that you could level up this project, lots of different ways that you can talk about accessibility, and then you're also just getting those wiggly learners moving. Sometimes I'm guilty of this myself. We just, we want to move and groove while we're coding. And so this kind of gets the whole body and mind into the process. So definitely, I encourage you to try those out. We have much more information about the face sensing blocks again in our learning library, so you can check out all those resources. And I also have a studio that I've created where I've just thrown in some examples that the Scratch team has put together so far and shared different ways that we are experimenting with the face sensing blocks. As we close out our session today, let's look at Scratch's creative learning spiral. We have imagined, created, and played. So now it's time to share and reflect and iterate. Imagine again. We want to celebrate a culture of getting unstuck and celebrate what was learned from missteps. For those new to Scratch, it can be helpful to get stuck and experiment a bit with blocks before you, as the facilitator, share tips and tricks. It can be powerful to model getting stuck and showing that it's okay to not have all the answers. That productive struggle is really valuable. And debugging and iterating alongside your learners makes you an active participant as well, as everyone learns through play and tinkering. You can find our debugging resources in our learning library for more. As we think about creating, iterating on our work, or debugging, keep in mind that pair programming can be valuable, especially when you have groups of different experience levels or interests. Pair programming is a practice where two developers collaborate, sharing a keyboard and mouse to work on the same task or project. One person is the driver who creates the code, while the other is the navigator who reviews, guides, and thinks strategically. Roles are then switched frequently to balance tasks and share knowledge. Together, the pair can create rich and dynamic projects, while they have opportunities to teach and learn from each other and explore different solutions. The pairs could divide up the tasks in a project. A student interested in art might create sprites, or a student interested in music or Foley might create sounds or musical scores, while another focuses on coding. Or students could pair up at specific moments to debug or add additional elements together. If you have a Scratch account, your project will save automatically. If you don't have a Scratch account yet, you can save your project to your computer. Click File and then choose Save to your computer. Next time you want to work on your project, go to scratch.mit.edu and click Create. Then click File and choose Load from your computer to upload your project. If you have a Scratch account, you can share your project and add it to Studios. Click the orange Share button to share your project to the Scratch community. Click the See Project Page button on the project editor to go to the project page. This is where you can add instructions and notes about your project. Now, other Scratchers can see and interact with your project. We promote many pathways, many solutions, because often there is not one right way to create your project. Some projects may reach a higher ceiling and have more complexity, while others can show how you have stretched to widen the walls of what's possible. We encourage learners to have fun tinkering, work with their peers, and design something to showcase their passion, and then proudly share their project when they finish. You can see our reflection and sharing resources in our learning library for more. Speaking of reflection, learners can reflect on their project creation and process as they complete a show and tell sharing sheet, or project gallery walk, self reflection, and peer feedback sheet, which can be found in our learning library. Their peers are encouraged to leave feedback or comments on the sheet for the creator as they view the projects in a studio or participate in a gallery walk. Just note that learners need a Scratch account and access to the online editor to participate in studios. In addition to the resources shared throughout these slides, I've shared here some additional resources where you can find help, inspiration, and information. Dive into our learning library for a wealth of materials that continues to grow. I've mentioned resources on the Achievery during today's session. The Achievery platform connects K-12 students to a new world of digital learning. And the Scratch Foundation is partnered with the Achievery to provide free beginner and intermediate creative coding lesson plans on a variety of topics for educators, caregivers, and learners. On the platform, there are project guides and accompanying videos that support the exploration of Scratch. Lessons are perfect for those who may want more guidance or scaffolds to start. And Scratch units cover a variety of topics, so students can take the skills they learn and create projects about things that relate to their passions and interests, while engaging in playful exploration. You can sign up to access for free on their website. Thank you for exploring this webinar and our resources today. I hope today's session has sparked ideas and will inspire your own unique projects that speak to your passions and interests.